Hello everyone, Namaskar, Raj Krishna this side. So today we are going to learn how we can find the coefficient of skewness from an ungrouped data. Okay, so the coefficient of skewness, if we follow Karl Pearson method, then it is given by mean minus mode divided by standard deviation. In case you are not able to find the mode, sometime for some data mode is clearly not uh, defined, so in that case you can use the other formula that we have. This in short we write SK. So the other one is 3 times mean minus median divided by standard deviation, which I am writing SD in short. And the value of this Karl Pearson coefficient, which we called as SK, this lies between -3 and 3. Okay, so this was a brief introduction about the Karl Pearson method to find the coefficient of skewness. Now let's because for this data we can clearly find the mode, which is because 25 is occurring 1, 2 and 3 times, and other values are occurring lesser than that. So we can say mode or is 25 because it is occurring clearly 3 times. Now we also need to find, now I'm using the first method, so first one, so I still need to find mean and standard deviation. So let's draw the table for that. For drawing table, we'll have to first write the x values, which I have is 25, 15, 23, 40, 27, 25, 23, 25 and 20. It's an ungrouped data. So for finding mean and the standard deviation, I am using the assumed mean method. So let's assume the mean. You can assume the mean any value from this x values. So let's say my assumed mean is a, which is, let's say, 20. So now I will have to find deviation of each x value from the assumed mean, which I have taken to be 20. You can take that to be 25, 15, 23 as per your wish. So I have taken it to be, let's highlight it, that my assumed mean is 25. It is occurring at 3 places. Okay, you don't need to highlight, I'm just highlighting so that it becomes easier for you to calculate. So now deviation from this assumed mean, so we'll calculate the difference from this assumed mean for all the values. So for first it is 0, 15 minus 25, so it is minus 10, 23 minus 25, so it is minus 2. Oh, sorry, I took the assumed mean as 20. No problem, I'm changing it to 25 now. So 40 minus 25 is 15. You can take, as I told, any value. Okay. So now 27 minus 25 is 2. 25 minus 25 will be 0. 23 minus 25 will be 2 minus 2, and 25 minus 25 will again be 0, and 20 minus 25 will be minus 5. Next, what I will have to do, I will have to calculate d square. Okay. So let's calculate d square now. So my d square will be 0 in this case. Luckily, because we took assumed mean as 25, so that gave us a bit of edge, because 3 times you are getting 0, so calculation will be a bit easier for you. Here it will be 100, then 4, then 225, I guess, then 4, then 0, then 4, then 0, and 25. That's it for the table. Now what we'll have to do is calculate mean from this, and the standard deviation. So for mean we need first of all this summation of deviation, which is sigma d. So that will be simply minus 12 plus 15, that is 3 plus 2 5, 5 minus 2 is 3, and 3 minus 5 is minus 2. Let's calculate it once again. Minus 12 plus 15 is 3, 3 plus 2 is 5, 5 minus 2 is 3, 3 minus 5 is minus 2. Fine. Now your mean, which let's say that x bar will be, what was your assumed mean, that is a plus summation d divided by n. So your x bar will be what we assumed, 25. So 25, what has come out to be the summation of d, that is minus 2 divided by how many data are there. So 3, 3, 6, 3, 9. So let's calculate this. So we have 25 minus 2 by 9. So this is coming out to be 24.77. So I am taking this approximately as 24.8. So we have found the mean. Now what is the next target? Next target is to find the standard deviation. So standard deviation is simply under root summation d square divided by n minus summation d by n whole square. So this will be under the root. Summation d square is what I need to find. So let's calculate it. So 100 plus 100 plus 4 plus 225 plus 4 plus 4 and plus 25. So this is coming out to be 362 divided by n is 9 minus summation d was minus 2, n is 9. So this is coming out to be, let's calculate it using calculator only. So under the root 362 divided by 9 minus 4 by 81. Okay. So this is coming out to be 6.33. Fine. So now you have got your standard deviation in front of you, your mean in front of you. Your mean was 24.8. Your standard deviation is 6.33. If you use the formula for coefficient of skewness, so that is mean minus mode. What is the mode? 25 occurred 3 times, so that is the mode, divided by standard deviation, which is 6.33. So if I calculate this, so I am getting 24.8 minus 25 divided by 6.33. So this is coming out to be minus 0.03, well lying between that range minus 3 to 3. So minus 0.03 is your coefficient of skewness, and we have found it using the Karl Pearson method. So that's it for today. We found the coefficient of skewness in today's video. We needed 3 things: mean, mode and standard deviation. Because mode was easily available, we used the mode, that was 25. Next we needed to find mean, which we found using the assumed mean method. Then we found the standard deviation, and that's it. Just plug in the formula to get your coefficient of skewness. So that's it for today. I will see you with some more videos, and the playlist name is Method of Dispersion. Thanks again.